So the procedure for the difference in two proportions is again that we have simple random samples from both populations, and secondly that we have independent samples. This is going to be the important thing here as well. And that our check, that X1, our successes and failures for the first population, our successes and our failures for our second population, again, are all greater than 5. So we do that little pre-check. And then the procedure is, again, it's the same thing. State the null and the alternative hypothesis, compute the z-test statistic, which is given by this guy here. And then if we're going to do the, depending on what our decision-making criteria process is going to be, either the critical value method or the p-value method, we can do that in step 3. Step 4, we make the decision, reject or fail to reject, and then step 5, if necessary, we can formalize our conclusions. So let's go back to our opening example. Over here, and notice that we do have 2 independent populations. Notice that we have a group of 24 to 34-year-olds, and we also have a group of 45 to 64-year-olds. Clearly nobody's going to be in both, not one person will be in both of those age ranges, so we have 2 independent populations. So let's come up over here and just write down some sample information. So X1, N1, so we will define the first population to be the proportion of 24 to 34-year-olds. So we have 27% of the 1,000 people. So if I want to know what X1 is, I just take 0.27 times 1,000, and I think we can agree that that's going to be 270, and N1 here is going to equal to the 1,000. So X2, the X2 is going to be the proportion for the 45 to 64-year-olds. So X2 is going to be 330, and N2 is going to be the 1,100. So our null and alternative hypothesis, so for step 1, we have to state our null and our alternative hypothesis. So here we want to know, do the data suggest that there is a difference in the seatbelt use between the drivers of 25 to 34-year-olds and those that are 35 to 64-year-olds? So here, is there a difference? So is that going to be the null or the alternative hypothesis? Survey says the alternative, so we need to go P1 minus P2 then is not equal to 0. And for our null hypothesis, P1 minus P2 is equal to 0. So for step 2, we need to compute our test statistic, but we need to come up with this P hat sub P first. So let's just note that P hat sub P is X1 plus X2 divided by N1 plus N2, which is equal to 270 plus 330 divided by 1,000 plus 1,100. So this is equal to 600 divided by 2,100. Yeah, I'm going to do it this way. In my notes, I did it with a rounding of 4 decimal places, but I'm going to run with this. So now we have to come up with our z-test statistic. So we have z is equal to, so let's just remember our test statistic then is going to be p hat 1 minus p hat 2. So p hat 1, can we agree, is 270 over 1,000? So 270 over 1,000 minus p hat sub 2, can we agree that's going to be 330 divided by 1,100? And then it's going to be minus P1 minus P2 under the null hypothesis, but P1 minus P2 under the null hypothesis is equal to 0. So this is 0, so we don't have to worry about that in our computation. Divided by the square root now, so let's just go 600 divided by 2100 times 1 minus 600 divided by 2100 times 1 over n1, which is 1,000, plus 1 over n2, which is 1,100. So again, I think the idea is going to be the same thing that we did before. Why don't we enter the numerator and crunch that, and then just go divided by, and then put all of this in the calculator as well. And we'll probably, just for consistency purposes, might want to put this guy in brackets as well, the first guy here. So when all is said and done, we should come up with negative 1.52. So let's just give this a whirl. So 270 minus divided by 1,000 minus 330 divided by 1,100. So press enter. So we should get negative 0.03. So far are we good, everybody? So then we just go divided by, and then we'll do the square root. And again, notice our open bracket here for the square root, so we'll do 600 divided by 2100. And now let's go open bracket, 1 minus 600 divided by 2100. Close bracket, open bracket, then we'll go 1 divided by 1,000 plus 1 divided by 1,100. And then we need to close bracket for this guy, so that's this bracket. And now we need one more closed bracket to close out for the square root. And if we press the magic button, we should come up with negative 1.52. And that, ladies and gentlemen, is how we roll. So now we need to come up with our decision-making criteria, so we can just draw a standard normal distribution. And we have a two-tailed test. So our alpha level is 0.1, so that means that 0.05 is in each of these tail areas. So to come up with the critical value, we just go inverse norm, 0.05, and we should come up with 1.65 when we crunch this. So our critical value here is negative 1.65 and positive 1.65. So our test statistic of negative 1.52 falls right here. So do we reject or do we fail to reject the null hypothesis? Fail to reject. So step 4 is we fail to reject. So what does that mean? So just one more time. The basic conclusion is we are saying that there is no difference, not in the seatbelt usage, but in the proportion of 24 to 34-year-olds and the proportion of 45 to 64-year-olds. Okay. So at alpha equals 0.1, the data indicates that there is no difference in the proportion of seatbelt users between the 24 and 34-year-olds and the 45 and 64-year-olds. That's how we would formally state that. Want to try another one?